All right, let's get started on chapter 3. So we are going to be doing algebraic expressions, and then we're going to be adding and subtracting those expressions. We're going to do the distributive property, and we are going to factor expressions. So as you can see by the title, this is all about expressions. So let's talk about what an expression is. We did this last year. This will be a quick review. An expression is simply well, we're talking about algebraic expressions. So 4 plus 3 is an expression, but that's called a numeric expression. So 4 plus 3 is an expression, mathematical expression, but this is numeric. We are going to be talking about algebraic. So algebraic expressions are simply expressions that have variables. So let's just talk about 2x plus 3y plus 4x plus 2 minus 6. Okay, so the biggest difference, if you remember from last year, between an expression and an equation is an equation has an equal sign, an expression does not. So we're not solving these, we are simplifying. So the main thing we're doing is simplifying expressions. All right, we're going to talk about how to do that. But first, let's just talk about a couple of things. So each one of these things up here, they are separated by a plus or a minus, are called terms. Okay, so these are all terms in our expression. And so what are our terms? Well, our terms are positive 2x, positive 3y, positive, I didn't need to put positive, sorry. Let's do that again. Comma, positive 4x, positive 2, and negative 6. Notice that each term has a either positive or negative value. And that's why each term is separated by the plus and the minus. So what we're going to learn is that we can combine these terms that are alike. So like terms. Let's go over here. So like terms, read along with me. In an algebraic expression, so an expression that has variables, like terms are terms that have the same variables raised to the same exponents. Okay, that simply means that just because let's look down here, just because these z's and this is a z, they are not like terms because it's not raised to the same exponent. So in order to combine like terms, they have to also be raised to the same exponent. So our like terms in b down here is 1z squared, positive 1z squared, and negative 3z squared. So when we combine, let's just do this one here first. We'll go out of order, that's fine. So when I look at these two, I have different signs, right? So I subtract, I start at positive 1z, go negative 3, and end up at negative 2z squared. I put my lines through my z's because otherwise they look like 2's. That's something I would recommend you guys get into. And then if you look at this, positive 5z and positive 1z, remember if there is no number in front of it, it implies that it is a 1. So 5 plus 1, same signs, add and keep, and we keep the positive, and we have simplified this. So an algebraic expression is in simplest form when it has no more like terms and also no parentheses. So later, once we learn the distributive property again, or remind ourselves, because we did that last year as well, but once we've distributed and then combined like terms, it is in simplest form, and that's what we're going to be doing. That's what we're going to be basically doing in this section. Okay, so simplify the algebraic expression, and you can see why we spent so much time on rational numbers, because you can't solve equations and you can't simplify expressions if you do not get the negative number part, if that's not understood. Okay, so let's look at these. We have let's use red here. We have a positive 6n and a negative 10n. So we basically take their coefficients and we combine them. Okay, so we have positive and a negative. So they are different signs. So we will subtract the two numbers. 10 minus 6 is 4. And you keep the sign of the bigger number, then you'll be exact. Some beautiful singing on this wonderful Sunday afternoon. So keeping the sign of the bigger number, which is 10, is negative 4 in. So I started with positive 6 in, went to the negative 10, which means I crossed 0. So on a number line, let's look at that. Here's our 0. Here was our 6. We went 10 to the left. So at this point, we have gone 6. We went 4 more to make 10, and we land on negative 4. Okay, so from a number line perspective, we started here, or they do the open circle, and ended here. Okay, hopefully that helped a little bit. Okay, let's look at the next one. So down here we have a negative 8.5W, a positive 5.2W, and a positive 1W. Hopefully you were thinking 1. Okay, so I'm just actually, because this is all addition, I can use the commutative property, and I'm going to go ahead and combine these two first because it's easy. 5.2 plus 1 is 6.2. So basically we have 6.2W, and that is positive. They were both positive, so it stayed positive. And then we're going to go negative 8.5W. So, different signs subtract, keep the sign of the bigger number, right? So we have negative, the bigger number here is the negative 8.5, or the 8.5 is the larger numeric value. So we're just going to come over here and subtract 8.5 minus 6.2. When we're subtracting decimals, remember to line up the decimals. 5 minus 2 is 3. Bring down my decimals. 8 minus 6 is 2. So I end up with a negative 2.3. And then the W. So we've combined the W's here to have a negative 2.3. Okay. And we can do the same thing with fractions, okay? So don't let these scare you. I feel like that's something that people do. They see fractions and they freak out. It's the exact same thing. So we are going to look at the y's here. So we have a positive 3/4 y and a negative 1/2 y. So different signs subtract. So we're going to subtract 3/4 minus 1/2. We will then set our common denominators because when we add and subtract, we need those. Hopefully some of you are thinking, ooh, 3/4 minus 1/2. I know that one by heart. But just in case you don't, how did I get from this 2 to 4? The 2 here. 2, 4. Well, I multiplied by 2, so I have to multiply this by 2. So I get 2. 3 minus 2 equals 1/4. So I have, and then keep the sign of the bigger number. Well, 3/4 is the bigger number, so we keep the sign of the bigger number because we want to be exact. Okay, and then constants also, if we go back to our rule about combining like terms, constants, which is what these are called, hopefully you remember that from last year. Numbers without variables are just called constants. So we have 12 minus 6. Well, different signs subtract. Keep the sign of the bigger number, then we'll be exact. And that is our simplification there. You can do the next one if you want. I would pause it very quickly, and then I'll write the answer in just 1 second. So it looks like we end up with negative 8y because same signs add and keep. And then we have a positive 13z. And my line through my z, so it's obvious. Okay, that's it. Basically, that's all we're going to be doing in this, just kind of simplifying these algebraic expressions. So if you have any questions, let me know.